So, all right, so let's get started, and apologies for the delay. I have a piece of hardware that apparently is very flaky I'm going to need to replace after this, but let's get started, shall we? So, last week we touched on loops and conditions. This week we're going to be going through objects, and there may be some errors in this slide. If so, I'm going to stop and explain where the inaccuracies are on it, or you can try and, find them yourself. Might be a fun challenge. So, let's begin, shall we? So we're also going to step back for a second. We're going to go through a little bit of the last couple weeks' materials, as this week's material really combines all of that together, and kind of need to understand the prerequisites, otherwise you're going to be lost here. So previously we covered variables, right? So a variable, in this case, it's just an abstract store of value, right? So what I mean by this is, I mean that our variable a, what it's going to do, it's going to store the value of 1, right? B is going to store the value of 2, and C is going to store the value of a. More specifically, it's going to copy the value of a, and it's going to assign a value of 1. And of course, at any point, if there are any questions during this, please feel free to stop and ask. All right. And functions, right? Briefly covered on this a bit, but what a function is it's a set of instructions that can be repeatedly used, right? So what this typically is going to be something like a print function, right? Or like, so for example, if I pass some variables into print, I can expect that it will output a specific result. And this is much more convenient than us writing the respective code to actually go through and print it off, right? Or more specifically, it's more convenient than us copying and pasting the code to print it off. All right. And on last week's, we covered loops, actually, which personally I find to be quite fun. But what a loop is going to do is it's just going to repeatedly execute the block of code that's in here. So this here is a while true loop, right? So what this is going to do is it'll print hello world until the program is stopped for whatever reason. Last week we also covered conditions, right? So conditions allow us to perform different tasks depending on a Boolean check, right? So basically, if this condition is true, then we'll do this. Otherwise, if it's false, we're going to do the else block down here. I promise the entire lesson will not be moving this quickly. This is just review of some of the prior weeks. Okay, so are there any questions on this so far, now that we've gone through like a quick little review of what we've covered so far? All right, excellent. So, topic for today is objects. We're going to briefly touch upon object-oriented programming here. And there is a massive disclaimer here to get in front of this, because this is an extremely opinionated area of programming, and everyone's going to have a different perspective on it. So, different people will prefer different approaches with regards to using objects. Some will say you should really avoid using them altogether. Others will say you should use them. Because of the nature in which Python is, Python being an object-oriented language, we're going to be covering it here. And also because it's the more common use case it's more commonly used in programming than the alternative, at least as of right now when this presentation is being done. That might not be the case in 10, 15 years. Who knows? But yeah, so to get into this, obviously their use is pretty nuanced, and there are multiple approaches, and there are multiple options and approaches here. So this is not the only way to build a program. We're merely covering how you would do so. Here's about alternative approaches. There's an entire area of programming referred to as functional programming, which avoids the entire concept and area of this whole paradigm, right? It means we're not really going to use the same design considerations. Not going to get into that here, but giving that context here for anyone who is curious and wants to look into other things. All right. We're also not going to get into the controversy of it. But just acknowledging there are different opinions on how this is implemented. We're just going to discuss about the technical implementation on what it is. All right. So what is an object? So, and this is where I start noticing that there were mistakes in this slide. So class example, right? Okay. So what is a class? Well, or more specifically, what is an object? An object is a mechanism for storing, well, specifically, it's a mechanism for storing related variables and functions encoded in a consolidated form. What does that mean? So what that means is we're giving a structure for us to be able to store functions that are related as well as data, right? Values. So for example, here we have a class, and in the case, this class will create an object whenever we go through the process of creating it. But what this is going to do is when we create a copy of the class, what we're going to see is that the values inside of it are x equals 20, y equals 10, and there will be a function defined called add that someone can call. All right, so if you were to hypothetically call this add function, what it's going to do is it's going to, using the self keyword, it's going to refer to the value of x within this instance of the class. And then it's going to add that to its own instance value of y. So let me step back and explain this a little bit more, because that's a lot of information to throw at everyone very, very quickly. The way I would see this and the way I would present this is this class is more of a template, right, of what's going to happen when you create this initial value, right? So whenever we create a copy of this class, which is done with, for example, this first line here, just by calling it as a function here, it's going to always refer to as a initializer, and it's going to go through and it's actually going to create a new instance of the object. Okay. When this new instance is created, what it's going to do is it's going to be created with these default values. It's going to be created with y equals 10, x equals 20, and it's going to be created with a function that does the following, where it adds x and y on it, right? In the context of a class, hello, I am continuing to have technical issues. Lovely. Wouldn't be VR chat if full body tracking did not proceed to break while on stage. So what am I referring to on this? Give me a minute to turn this off. Okay, that'll work for now. Avoid some issues on this. But yeah, so effectively that's basically what it is. It's going to go through and create it. The keyword that we have here, self, what that's referring to is that's referring to the instance of our object, right? It's referring to the copy we have created. So whenever I call self.x, I am referring to the value that is within the copy of the object I have created. If that all makes sense. Also, what is the output of this? This is a runtime error. This is supposed to say my example.x. But does anyone have any questions on this? Because that's a lot of information to throw at everyone very quickly in one slide. All right, well, That works. Okay, so let me go to the next slide. If anyone has any questions on this at any point, feel free to interrupt or feel free to just chime in with a question and I'll be happy to answer it. Okay. And this is probably a pretty valid statement considering everything that was just said here. The genuine question of why should I even care? Considering this genuinely feels like a much more complicated way of doing things. Technically speaking, everything you do here, everything you've been doing up to this point could be done without classes. It's going to be a lot harder. It's going to be harder to stay organized and structured, but technically speaking, you're able to do it. Programming concepts and programming languages existed long before this concept was available, and yeah, it's been done before. The logic on why this is implemented is for things like organization, right? It's for things like organization, and it's to make it so that way it's easier for you to see what is going on within the code, right? That's really pretty much it. The practical reason on why you might have to use this is sometimes a library or someone else's code will also tell you to. So, kind of hard to get completely away from it. All right. So let's have some fun with this, shall we? So let's compare the code below with that on the right, right? So over here, we have values that have been defined as, please ignore the self that's on here. This was a copy-paste error. So we have values here for x equals 4, y equals 10, and we have these functions off by themselves, right? Self is an error. Please disregard on this slide. On the right-hand side, we have a class, referred to example, and this is going through, and this is basically taking all this data, all these variables we have, and the functions, and just consolidating them down into one place. This is going to be a little bit easier to work with because you're going to have all of your individual values contained within this. You're also going to have your functions contained within it, and it just makes it a little bit easier to stay organized. Realization that this copy-paste error was done on the last 3 slides. Anyways, so for the curious, when the worksheet goes up this week, slide link that you see will have these corrected. They're just not in World, and corrections have not been applied yet on the online copy. But whenever you are looking at this, whenever we do post the list of resources, it's going to have all these corrected. Okay, so let's break down what this is. Kind of gone a little bit into this on the last couple slides, but let's give this a shot, shall we? So at the top is a class definition. So what I mean by this is your class is going to be defined by the class keyword. Right, so the logic for this is class, and then the name of the class. All right, cool. Here we have some variables that have been defined. Your x equals 20, your y equals 10. Excellent. Then we have a few functions that have been defined, and these look, for the most part, pretty similar. You're going to notice that there has been a self keyword added here. This is just so we can reference within our copy of the class for whenever we are doing operations on our variables that we have above. And to create a new, and I actually even added a little note here. Self here is referring to ourselves, our internal variables and functions. And to create a new class instance, well, we just call it almost like we would as a function. And that'll create a new copy. Are there any questions on this so far? Excellent. This is also one of those things that is genuinely easier to learn by going through and actually doing it. So I'm sure when the worksheet is done, not worksheet, when the workshop is done later this week, that it'll be a good opportunity to put some of this into practice, because this feels very theoretical, because when presenting it here, it kind of is. Okay. Common way to reuse code in classes and to inherit from them is typically done with the super keyword. Okay. So sometimes you will want to have a class such as this one. You will want to create a class that inherits all of these values, right? Sometimes you'll want to inherit them so that way you can then change only a couple of them but keep the rest. But in a couple cases, you just want those set of values, or you want to add more ones. Rather than copying and pasting all the code, you can make use of a keyword referred to as super, right? And that will allow you to go through and, well, what that will do is that will let you go through and reuse the existing code. Okay, so let's have some fun, shall we? So on the right-hand side is our class that we want to use some code from, right? So this is class animal, right? Okay, so we defined a function here called headpat, and it's going to print no human, right? Human, do not give me a headpat, please. However, let's say we want to extend this class, or let's say we want to completely change what is being printed here, right? So what we can do is we can define our class, our child class, with the variable we want to, specify the class we are going to inherit from, define our initializer, or in some languages known as our constructor, and call super within this. This will cause us to inherit this. Kind of a moot point, considering we're about to override it, but for the purpose of showing how that works, there we go. And then we're going to change the value of headpat, so that way it will print meow, right? So I guess I should ask the audience a question here. If I were to call the headpat function on these, what is going to be the resulted print statement? What's going to be the resulted output for each of them? If I call the headpat function on an instance of animal, or if I call it on an instance of cat, what am I going to get?
With cat, you're gonna get meow. Versus
Exactly.
if you just call animal, it's just gonna be no human.
Exactly. Nail right on the head. This is a very powerful concept, because what you can do is you can have some really complex logic in your function, in your superclass, and some logic that you don't want people having to rewrite or yourself having to rewrite. And you can then have the child class go through and implement whatever couple little details you want to change. Like, let's say you have a class instance of something called player in a video game, right? Okay. Maybe you want all the information to be the same, with the exception of the stats that are provided, right? Like, you have specific stats for whatever type of class you're playing as, right? Like, let's say you have a ranger, you have a soldier, you have a mage, you have whatever. And you want to do something a little bit different on it, you could inherit from the player class and override the logic as you see fit for that. And that would save you a huge amount of time on having to re-implement all this. If this sounds like it's a good way to introduce very complex errors that are very difficult to find, you'd also be correct, but that means that's how programming goes. You're less likely to introduce an error by doing that than you are by copying and pasting the code as you change it. Because you might decide, oh, I'm going to change it in one place. Oh, whoops, I forgot to change it in the other 10 places that it was present. Speaking from experience on that, do we have any questions so far on any of this? Oh. Yeah, that makes sense. So, okay. So, I'll go back to the slide right before this. Because this is, I'll admit, maybe these slides should be in a different order. So, I'll go back to the code example and I'll show what this is referring to. So, what this is referring to is if you want to effectively copy all the variables and functions from another class, you would have, like, let's say you have a class called animal, right? You need to do two things, right? You need to call the super function, and you also need to define what class you are going to extend, right? Or inherit from. And that's what this keyword is for super. That's effectively what it's doing. Hopefully that helps. I don't think that's exactly what I said previously, but it's probably the same intent. Gonna jump back to the last slide, but do we have any other questions? That's a good one, actually.
Not
Like it.
exactly a question,
Go for it.
but this kind of reminds me of how I've been explained when you're making games, you would use this so you wouldn't have to like program every enemy. You would just create an object, the enemy, and that you could instance multiple times.
Exactly. Yeah, that's a very similar concept, right? Like you would create like you have a class enemy, right? And you decide, and you go through and you create a new copy of the enemy, right? Maybe you create a type of enemy, but that type of enemy has specific characteristics, right? That you want to give it. Maybe you want to give it a different attack. Maybe you want to give it different stats. You can go through, if you choose to, and implement that as a class, right? But yeah, it's a very good way to look at it. And in game programming, it's very commonly used. The part where this is not as commonly used, because I know like on the earlier on in this, there was the obligatory disclaimer of there are multiple different ways to write programs and like, right? Some web applications, specifically ones with very large amounts of data, don't really make extensive use of object-oriented programming because there is an entire set of languages that are just not really designed around that concept. So so for most of your applications, like it makes sense, but yeah, there are always cases where it is not going to be used. And to be clear, most web applications are object-oriented. I'm referring to like extremely niche, high-scale systems that like there's not that many of in the world being used. Elixir is a fun example. Yeah. All right. Do we have any questions, additional ones, or comments at all?
There's nothing in the Discord or Twitch stream.
Okay. Well, obligatory disclaimer. It's if you're still wrapping your head around a little bit of it, there's a reason that objects are covered very late in the semester for introductory computer science class, like courses in university. At least that was my experience when I was in university. So it's a fairly advanced topic, so for that reason, so if there are any questions, feel free to ask in the Discord, and myself or someone else will go ahead and answer them. But on that note, I think we're probably good to call it a wrap on this one.